this assessment asks us to draw the transition state of both steps of the addition of HBr to an alkene. I've gone ahead and shown on the reaction coordinate diagram what the two steps will look like because this is a Hammond postulate question. And so using the Hammond postulate, we can look at this endothermic first step and say that the transition state is going to resemble the intermediate. Let's draw an intermediate, a transition state that looks like the intermediate of the reaction. The best way to show this is to indicate that the carbon-carbon pi bond is mostly broken. So we'll do that with multiple dots. We'll show that the carbon-hydrogen, the new carbon-hydrogen single bond is mostly formed, and the HBr bond is mostly broken. We'll elongate that quite a bit to show that. The other way we can do this is using the charges. So if we look at the charges in the intermediate, we have a full positive charge on carbon and a full negative charge on bromine. We can indicate that by using a very large partial negative and a very large partial positive. This represents a transition state of step 1. If we look at what's happening in step 2, we're now going to have Br minus attack that positive charge. But because this is an exothermic reaction, so going from here to here is exothermic, we expect our transition state to once again look like what was the starting material, in this case, the intermediate. This one's going to be a little easier to draw because essentially what we're saying is the new carbon-bromine bond is barely formed at all. So we can draw a long dotted line to show that that bond is barely formed. And again, we can use the charges, a big partial negative and a big partial positive, to indicate that that carbon-bromine bond is once again barely formed. How does that match here? Well, in this carbon, we had a full positive. We have an almost full positive. We had a full negative. We have an almost full negative. And so this represents the transition state of step 2.